This is lab 2 by me, Nikki Chris. So lab 2, basically, it worked off of the concepts of charge and the properties of matter. Through this lab, we can see the fact that matter can have temporary induced dipoles due to being exposed to an outside electrostatic force, such as a charged piece of tape. The main goal of this lab was for us to calculate the amount of excess charge on a piece of charged clear tape. So for presumptions for this lab, in the lab I used the principles of force and electric force in order to determine the charge on the tape. In knowing that tape A was exerting a force on tape B, one can surmise that there must be an equal and opposite force acting on tape B as well. This is due to tape B having zero acceleration or momentum, meaning that the net force acting on B must have been zero. So I concluded that this opposite force must be gravity, and I concluded that the force due to gravity must be very close to the force due to the electrostatic force from tape A. Essentially, they're equal. So for data for observations for this lab, they're the same from lab 1. The length of my tape B was 21 centimeters or 0.21 meters. The mass of this piece of tape was 0.00021 kilograms. The distance between the two tapes when one began to flow above the other was 0.015 meters. The magnitude of gravitational force on the two pieces of tape was 2.06 e to the negative 3 newtons, and the magnitude of the electric force on the tape was 2.06 e to the negative 3 newtons. So they were equal according to my calculation. So for coding, in my code I initialized the tape objects in the form of two rods, each composed of multiple point charges, and then created an electric field function like the ones we did in lab 0 and lab 1. I then scaled the electric field vector arrows as well as the electric force arrow, as well as the gravitational force, after finding Q by essentially guessing and checking until the magnitude of the gravitational force equaled the magnitude of the electric force. And so in the end, after all that trial and error, I found Q to be negative 3.69925 e to the negative 17 coulomb. This is the output of my code. So you can see the red spheres model tape A, the blue spheres model tape B. The green vectors are the electric forces, and the yellow arrow pointing down is the gravitational force. And you can see in the output for the code, it just prints statements declaring the electric and gravitational force. So if we had modeled the lab as one charge, the results would have been less accurate, as the pieces of tape, each piece of tape individually, acts like multiple point charges anyway, instead of one. This is because obviously, a tape has many electrons, so it has many charges. So if you model it as one charge, obviously you're going to be quite inaccurate. But if you have many charges in your model, then you'll be much more accurate. And assumptions made when calculating the charge on the piece of tape included definitely ignoring air resistance, as well as assuming that each U-tape had the same amount of charge evenly distributed along the length of the tape.